Okay, Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam, Doktor.
How are you? Good?
Fine, Alhamdulillah. How are you, Doktor?
Good, Alhamdulillah. So how was your birthday pula dah? Apa Aidilfitri celebration?
Good.
Good Alhamdulillah.
Alhamdulillah.
Okay lah. Asalkan selamat.
Dapat beraya rumah lecturer.
Oh ya ke? Lecturer siapa pergi tu?
Dr. Pa.
Dr. Pa. Meraya
Dr.
Dr.
sakan.
Amira. Sebelum dia bersalin lah.
Sebelum salin. Oh sempat Okay. Saya tak berani nak keluar. Ada polis duduk round kawasan rumah saya tu. Tak boleh nak keluar.
Oh, patut lah.
Raya dekat ni je lah. Dekat rumah. Dengan anak-anak. Okay. So kita start. We continue. So last week before our Aidilfitri holiday, so I have shared you a video link of Prof Nasir's video lecture. So in Prof Nasir's video lecture, he mentioned about partition, okay, the entropy of the partition, joint partition, and also some of the examples. So today I just want to recall and repeat a bit what has been discussed in the video. Is that okay?
Okay.
Dah tengok belum video tu?
Belum.
Belum, ceh. Tengok lagi punya. Cuti raya sungguh nampak. Okay. So today I'll just go through a bit fast if we can and consider the exercises that Prof Nasir already discussed in the lecture. Okay? Okay, so consider we have the probability measure space with this triple, and we have psi given the partition psi that has n element, and we have the second partition eta, we have m element, and the third partition zeta, we have l elements. Okay. Wait a minute. All right. So if we have a trivial partition, so we have zeta is equals to some v, and the trivial partition, that means you has only one element in the partition, that means the whole X. And you have where the conditional entropy of psi and the trivial partition is equals to the entropy of the original partition, which is psi. Okay, we have the first one. So we have considered this one, entropy of psi joined with eta, second partition, given that the third partition is equal to the entropy of the first partition, given that the third partition plus with the entropy of the second partition, given that psi joined with zeta. So this one we have already shown in the previous lecture, in lecture number 10. Okay. Next, if this zeta is trivial, again we have this is equal to x, and we found the entropy of psi joined with the second partition is equals to, so if zeta is trivial, so that means we just ignore zeta. So you have only this apa equation formula. So entropy of psi plus entropy of eta given that psi. Okay, so we just cancel the zeta if the zeta is the trivial element. Okay, next we consider the second one. So this we will consider a non-decreasing with respect to first argument. So what does it mean by this? So if you have the entropy of psi given that zeta, okay, so this is less than or equal to the entropy of the second partition given that the third partition if we have psi is less than or equal to eta. So for non-decreasing with respect to one argument, so the first argument psi here given that zeta, we will have the entropy of this will be less than or equal to the entropy of the second with respect to the zeta, because if we have this zeta here, eta here is less than, sorry, if we have this is less than this. So kalau okay, kalau psi less than eta, so that means we will psi less than eta, that means we will have the entropy of psi will be less than or equal to the entropy of eta with respect to one argument which is zeta only. Dia kena the given that ni adalah sama, baru kita boleh buat only that we can have the non-decreasing with respect to one argument. Okay.
Doktor yang tu psi
Mana? Ni.
Yang
Ya, psi. Sekejap, saya tulis betul. Psi. Okay. Let's go. Okay. Next. Can we move on? Abida Salin?
Sudah.
Alright. Okay, for the third entropy. Okay. So if T is measure preserving transformation, then you will have the entropy of the inverse, the pre-image of the psi, given that the pre-image of the second partition is equals to the entropy of only the psi, because they are major preserving transformation. So we will have respect to this formula. So if psi is equals to V or equals to the trivial partition, so you have the entropy of the pre-image of psi is equals to the entropy of psi. So this one you can try to prove it by yourself. Okay, you can also try to prove this. So I put this as number 2 and this is number 1. Okay, you can try prove 2 by using 1. So this is the condition for in order for you to prove number 2. Senang je. This because we use the fact that T is the major preserving transformation. So if you remember what is major preserving transformation definition, you will get the measure of the pre-image. It will be the same with the measure of the element of the set. Okay. Next, we go to okay, now we will have what? Entropy of psi, given that the second one, eta, is equals to, so if you want to find the entropy of partition with respect to partition, which formula that do you use? Yang ni kita use average or kita use the normal one?
Normal.
Normal tu maksudnya ada log. Are you sure? Because this is partition, this is partition. So you use the average. Ingat tak? This one we use the average because we have partition with respect to partition. So if we want to find the entropy of partition with respect to partition, you have to use average. Baru dalam average tu baru you get the normal one, which is respect to element of the partition.
Yang kena negatif tu ada kan?
Ya, yang ni baru ada negatif log mu. Sebab
Okay.
ini BK ni adalah dalam kalau partition dengan partition, entropy conditional entropy partition with partition, you have to use average dulu. Dalam average tu baru ada yang ni, the log minus log something. Okay. Alright, let's try to look at this. Okay. So from the left hand side, I want to use the number 2 here. So from the left hand side, I have the entropy of the pre-image of psi with respect to the pre-image of eta is equals to so kalau kita nak guna dia punya inverse ni, kalau dia T is a major preserving transformation, so you can use the same because this is with respect to partition, this is respect to partition, so you will have also the average. Okay, 1 until m mu of what? T inverse, betul tak? Sebab yang ni adalah dalam bentuk inverse. So the conditional measure also in inverse. So in inverse of the element in the second
BK.
partition, BK, yes. Multiply with the entropy of this one lah, inverse of psi, given that inverse of element of the partition, element of the partition eta. Okay. Now, dah sampai sini, you can try to prove lah. Prove that the entropy of psi, given that BK is equals to, maksudnya you need to find this one. So since this is measure preserving transformation, so you know the entropy of inverse here is the same as the with respect to the pre-image of the inverse of BK. You can use this important information since our apa tu? Since our pre-image of psi is since T is a measure preserving transformation, then you can show that they are the same. So what about the measure? What about this measure here? What do you know for the measure preserving transformation? Mu T BK is equals to what?
Mu BK.
Mu BK. So you got all the information. Now you can apa tu? Try to rewrite balik in terms of to show that the left hand side is equal to the right hand side. Okay. Okay, let's try to do the exercise for more understanding. Exercise. Okay, again, let X is this set of 0, 1. So I have a partition psi that has two elements, 0, 1, 2 until half to 1. And then I have the second partition that has 4 elements, 1/4, 1/2, 1/2, 3/4, and 3/4, 1. Okay, so now I want to check whether this psi is less than or equal to eta or not. Are they less than or equal to eta? So how can you check? So first you need to know, you need to find, if you look at the partition elements in the psi and also in the eta, so they are actually refinement, correct? So you will have this the element of psi is less than element of eta because psi is the refinement, bukan, eta is the refinement of the psi. Betul?
Betul.
Ya. Yeah. Tak ingat dah?
Baru tengok ni.
Refinement yang lagi kecil tu kan?
Ya? Yeah?
Macam apa tu?
Macam terbalik je.
Saya lagi kecil.
Psi lagi kecil?
Oh tak tak. Betul lah.
Betul? Psi lagi kecil, betul tak?
Betul lah.
Macam mana ni?
Betul betul.
Betul. Okay. So check, we can see that psi is less than or equal to eta, betul?
Betul.
Sebab apa psi less than or equal? Sebab 0.5 tu adalah the union from 0, 1/4 dengan 1/4 dengan 1/2, betul? So because these two elements here is greater than the first element in the psi, so that means psi is less than or equal to eta lah. Okay. Okay, now let's find the entropy. So I know this is symmetric because 0, half, half 1, 0, 1, 4, 1, 4, 1, 2, 1, 2, 3, 4 and so on. So this is symmetric. Sebab the partition is divided equally in equal size. So I can get kalau according to our calculation last from our previous classes, entropy of psi is berapa for symmetric case? What is the value? Log 2, betul tak? Sebab dia ada dua partition. Dua elemen. Boleh?
Boleh. Kena
cari balik. Okay, kalau entropy of the eta, how many do you get? Sebab dia symmetric dan dia ada 4 elements in the partition, so this is log 4. So can you show that psi is less than or equal to eta? Yes, because you see that entropy of psi is less than or equal to entropy of eta, since this is log 2 and this is log 4. So that means you have shown that your calculation is correct lah. Okay, so far at this part.
Okay.
Okay, so try to find balik entropy of psi ni berapa. We have done this in previous class. I think class 9 kot ke class 8. Right? Class 9. So, next. Home task. Okay, let zeta be this partition that has the elements 0, 1/4, union with 1/2 and 3/4. And another one, you have 1/4 with 1/2, union with 3/4 and 1. Okay, this is the elements in the partition zeta. So you can compute, try to compute the entropy of psi given that zeta and entropy of eta given that zeta. So psi dengan eta ni adalah sama, guna the from previous exercise. From previous exercise, I have psi is 0, 1/2 and 1/2 and 1, and eta I got 4, 0, 1/4 until 3/4 until 1. Okay, you got 4. Okay, you use the same element in psi and also eta. Try to compute this entropy. And then check. So this is the first one. Check the entropy of psi given that eta is less than or equal to the entropy of eta given that zeta. Is this true? Statement number 2, is it true? Okay. Finish? Finish, Salim?
Yes.
Okay. Okay, now we go to another exercise. Okay. Again, I consider this set 0 until 1. M is a usual Lebesgue measure. Okay, so I have psi is given by this partition. Again, the same. I like to have the symmetric. And then eta is this 1/4 to 1/2. 1/2 to 3/4. And 3/4 to 1. Okay. So you shown already that your psi is less than or equal to eta. Okay, you show already. So now let us consider dyadic transformation. Okay, so apa function dyadic transformation? You will have Tx is equals to 2x mod 1. So how can you, if you draw the graph, how does this graph looks like? So I have, say I have graph, okay. So kalau 0, x to 0, Tx is 0 lah. You got here. If x is, since x is between 0 and 1, so you can take 0.1 for example. X2 can be 0.1, 0.2, 0.3, and it can be 0.001 and so on. So the graph will look like this. For the case of and another one. So if x to half, if you got x to half in mode 1, what do you have? You got 0 balik.
Betul.
Boleh tak? Betul So you will get this kind of graph lah. So this one is t of x and this one is x. So the last one, this one is 1 lah. And this one also is 1. So this is how the graph looks like. So now we want to find the pre-image of the T, the apa tu T, dyadic. Okay, you know the pre-image of you know the partition, the element of the partition here, 0, half, half, 1, and eta. Now let's try to find the pre-image of the partition, but in dyadic form lah. Okay. Now, let's write color green. So I have the pre-image of partition psi. So the pre-image of partition psi has 2 elements. So you should write the pre-image of the first element, which is from 0 until segment half. And another one, the pre-image of half to 1. Is that okay, this part?
Okay.
Okay, now let's try to find what is the pre-image of 0 half. Tengok dekat graf. Kalau 0 dengan half, pre-image, so you project to what? From x axis to y axis or y axis to x axis? Actually pre-image.
Y to X.
With X.
Y to x. So from 0 to half, what do you get? What is the pre-image for these two?
0 to 1/4.
So 0 to,
And
correct. So you will get ni 1/2. So you project here, right? Here, and then you go to x. So you will get 2 lah sebab we have two garis kat sini. Two straight line here. So you will have 0 to 1/4. Another one?
1/2 to 3/4.
Correct. So how you should write these two segment? Oh, macam mana kita nak tulis union, pandai. Macam mana kita nak tulis? Kita tulis in terms of union. Okay. You have more? Do you have more? Union dia 2 je lah. Okay. Okay, now from finish kan? Dah tak ada dah. For the 0 and half segment. Now for the half to 1.
1/4 to 1/2.
Correct. So you will have 1/4 to 1/2 union with so
Yes, from one.
from this you go back. You got here lah. Then you have 3/4 to 1. Okay. Now I can write this. Let's say I can write this as the pre-image of the first element A1, and this is the pre-image of the second element A2. Okay. Now, can you try to find the pre-image for eta, the second partition? I give you time for 5 minutes. I come back around 10:40.
Boleh.
Boleh eh? Okay. So how many elements in the pre-image of eta?
4.
4. So the answer is pre-image of eta. So you will have 0, 1/8 union with 1/2, 5/8. And then 1/8, 1/4 union with 5/8, 3/4. And another, the third one, 1/4, 3/8 union with 3/4, 7/8. And last one, 3/8, 1/2 union with 7/8 and 1. Okay, correct?
Correct.
Yes.
Okay, good. Okay, for the case of the adik, now you can find the pre-image. So if the question asks you to find and show that the left-hand side is equal to the right-hand side, and it give you the values of the element. Okay, you can find to show one by one lah. First, show left-hand side, what is the value, then right-hand side, what is the value, and show that they are the same or they are the less or equal and so on. Okay lah, kita ada lagi sikit conditional example. Okay, now let us compute the conditional entropy. So this conditional entropy of psi given that partition eta. So since this is the entropy of partition with respect to partition, so you have to take the average. Okay, from 1 until 4, since eta we have 4 elements in eta. So mu bk, or the conditional entropy multiply with the conditional measure multiply with the conditional entropy with respect to each element. Okay. So now kita we use the same element in eta and also psi. Senang. Okay, we use the same example. Partition. So first you found what? Psi of B1. Next, psi of conditional entropy of B2. Conditional entropy of respect to B3 and conditional entropy with respect to B4. So the formula to get the first one, let's say psi with respect to B1 is equals to mu of minus. Okay, sebab kita ada minus sebab ni with respect to element in the partition. So dah boleh guna the normal formula je lah. So minus mu B1 of A1 multiply with log mu a conditional measure B1 of A1. Tolak mu B1 of A2 multiply with the log mu B1 of A2. Boleh Pak ni? Oops. Boleh Pak ni? Boleh. Ingat kan? Okay. So you found already actually this value. What is the value for this conditional entropy? Sebab yang ni kita dah cari sebelum ni. Dalam lecture let me check lecture berapa tu. Lecture 10. Lecture 10. Lecture 10 Yeah. So I just use the value and then I just put in my calculation here. So what do you get?
1/4.
1/4, correct. So I find mu b. First I find the conditional measure. This is I got mu a1 intersect b1 over mu b1 is equals to 1/4 over 1/4, which is equals to 1. Next, I find mu b1 of a2, mu of a2 intersect b1 over mu b1. And here I have mu of empty set over 1/4, which is equals to a 0. Okay, so this one for the first case, for the with respect to b1 only. So I have entropy of psi of b1 is equals to minus 1. Because mu b1 a1 is 1, so I have minus 1 log 1 minus 0 log 0. So this give you 0 because log 1 is 0. Okay, so next I can find the next unconditional entropy, H of entropy of psi b2. This is equals to minus mu b2 of a1 log mu b2 of a2 a1 minus mu b2 tolak sini lah, minus mu b2 of a2 log mu b2 of a2. And again, you find the measure, conditional measure of mu b2 a2 and mu b2 a1. And again, the same, you will get 0. Okay, sebab mu b2 a1 is mu a1 intersect b2 over mu b2. This is 1/4 over 1/4. So you got 1. And mu b2 of a2, you will get 0. Okay, sebab apa? Kalau salah satu dia 1, mesti yang lain tu 0. Dia sama ada 0 sampai 1 je. Okay, so the next entropy with respect to b2 will be 0. So the same for the case of respect to b3, respect to b4. So b3 you will have 0. Psi of b4 you will get what?
0
Are you sure?
ke 1.
0 ke 1?
1 kot, dah semua 0.
Dah semua 0 kan? Could be 1, could be, you can check. Okay. So the entropy, kalau entropy tu 0, maksudnya tak ada randomity lah. Undeterministic. Tapi, yeah. And then you have to find the average kan? So maybe 0 or 1, you can check. Maybe it got values. Try. So kita tengok mu b4 of a1 log mu b4 of a1 minus mu b4 of a2 log mu b4 of a2. So first you find mu b4 of a1, what do you get?
Zero.
mu of A1 intersect B4 over mu B4. You got 0. Mu B4 of A2 1. So again the same you got. So if you put here the values, so here 0 minus 0 log 0 minus 1 log 1, which is give you also 0. So all of them 0. Okay, now nanti kita come back to this, why this become 0. Okay. Now we will come back to that later. Now you need to know before we understand why is it happening. So we got this join ya. Kita cakap kita ada join ni. So I have psi join with the eta with the entropy of eta plus entropy of psi given that eta. Okay. Yang ni kalau join two partition. Nak cari dia punya entropy. So let change order. Okay, change the order. So I have the entropy of eta join with psi is equals to the entropy of eta plus the entropy of psi dengan eta. Okay, kita try change order dekat part sini dengan part sini. Tapi dia punya right hand side sama. Okay, from our previous calculation, we got we got the entropy here is equals to 0. This one is log 4 because you got 4. This one is 0. But for the case of H entropy here, for the green thing here, green, what do you get?
Log 4.
Log 4, correct. So this one you got log 4. So what does it mean?
Trivial.
That means yes, trivial. Tapi yang ni for the case of join, so I have psi join with the eta. Okay, is equals to log 4 plus 0. Betul tak? Since psi is less than or equal to eta, then this give you if and only if psi join with the eta is equals to eta. Dia macam ni. Apa yang dia nak cerita ni? Okay, first kita nak, let's say we have this entropy psi and eta. So psi and eta is equal to this entropy of eta plus dengan entropy of psi given that of eta. So if we change the order in the left hand side, so I have eta join with the psi, tapi dia punya right hand side is still the same. Okay. And from previous calculation, we know that the entropy of eta is log 4 because sebab kalau 4 ni dia ada 4 elements, so they are symmetric, so we have log 4 lah. And the conditional entropy for this is equals to 0. Because of what? Ni lah yang kita kira tadi ni. Semua ni. Ni kan nak cari apa? Conditional entropy of this, right? This one you got all of them is 0 because the calculation semua 0, 0, 0, 0. If you take the average of 0, also you got 0. This one. So this means that the entropy of psi joined with eta is actually equals to this, equals to the eta joined with the psi if psi is less than or equal to eta, barulah kita akan dapat psi join dengan eta is equals to eta. Dia macam paling maksimum join dengan psi dengan eta ni boleh join adalah eta. The maximum they can join is the values of eta. Sebab eta ni kita we have the more elements in psi. So if they are joining them, the entropy, okay, the joint partition here will be equal to eta, the maximum. You faham tak? You faham? Tak boleh? Okay, macam ni. Kalau kita ada psi, okay, kita ada psi, ada 2 elemen betul? And kalau kita cari eta, kita ada 4 elemen sebab ada kita divide by 4. Betul? Sebelum ni memang psi memang less than or equal to eta. Betul?
Betul.
Okay. So kalau kita join between psi dengan eta, okay, kalau kita join, dia tak boleh jadi lebih daripada eta. Entropy dia. The values of the entropy if we join between psi dengan eta ni, the values of the entropy of the joining here is equals to log 4. Maximum dia log 4. Which is the value of h of eta. Sebab dia tak boleh exceed the dia tak boleh exceed the biggest partition here, which is eta. So kalau you have this condition psi less than or equal to eta, so the joining entropy of psi join with eta, you will have only eta lah. Then you got join them. Join partition will be only eta, the maximum one. You take the maximum partition tu. Okay. So I can say H entropy of psi join with eta is equals to log 4. Then we will have entropy of eta. So we will get this. Okay. Questions this for this part? No? Okay.
Tak ada.
Okay, good. Okay, now kita go for remark. So for the important remark, so what if you want to find the entropy of the pre-image of psi given that of the pre-image of eta? So what is the values for this? So previously you will have entropy of psi given that eta is what? 0, right?
Yes.
Okay. So what is the entropy for the pre-image of these two partitions? Conditional entropy.
0.
Also
Zero.
0 because they are measure preserving transformation. So you will get this. So you got 0 because all of them are symmetric. The entropy are symmetric. Okay. With respect conditional, this one, you will get 0 if all the elements in the partition are symmetric. Sebelum ni you got, you found the entropy of with respect to partition, and then kalau dia tak apa tu symmetric, maybe you can get positive values here. But since we have symmetric punya case, so you got 0. So if important remark, if the pre-image of if T is the measure preserving transformation and the entropy of the conditional entropy of the partitions are 0, that means you will have the pre-image of the partition, the conditional entropy of the pre-image of the partitions also 0. Okay, so you can show, macam ni nak show, first you find the pre-image of psi given that pre-image of eta. So you have to find the average because this is with respect to partition with partition 4. So you have mu of B, mu of pre-image of BK multiply with the entropy of the pre-image of psi given that pre-image of BK. Okay, now you have to find ni lah. First, you find this one lah. H entropy of the pre-image of psi respect to the pre-image of B1 and the pre-image of psi respect to the pre-image of B2 and so on until B4 because you got 4. So if I show you the first thing, the first one here, so what is the formula? So since this is the pre-image of psi with respect to the element, okay, so I want to find the measure because you have the measure in there. So this is okay, sum of minus mu of BK, mu of T, BK log mu of T BK of B1, sorry, B1 A1 AK. So because of and then you have to find the apa measure here. Banyak kerja. So first I find the measure B1. Oh sorry. Kenalah ada ni sebab dia ada inverse. Log. Banyak ni. Mu T inverse B1 T inverse A2 log mu T inverse B1 T inverse A2. Okay. Lepas tu cari satu persatu measure So you got A1 here. This is equals to mu of T inverse of A1 intersect B1 over mu of T inverse of B1. Okay. So since what? T is measure preserving transformation. So I have measure of T inverse. So you can use the inverse punya properties. So I have A1 intersect B1 over measure of T inverse B1. And since they are measure preserving, so they are actually the same lah. Measure of the inverse will be the same of the measure of A1 intersect B1 over mu B1. Okay. Boleh?
Boleh?
Boleh. Okay, so you can find measure ni dah dapat. Now measure for itu pula. So if you calculate all of these calculation of the pre-images, so you will get the pre-images, the entropy of the pre-images with conditional entropy also will get you 0. Okay, this give you the of psi respect to this eta is equals to 0. You will get 0. Okay. Okay, so okay. Now for the entropy of psi, this is equals to the formula lah, minus of k from 1 until n mu ak log mu ak. They must be positive or apa tu? Non-zero, bukan zero. They are non-negative. So if let T be the measure preserving transformation and psi that has n elements. So I have the join. Psi join with the pre-image of psi. This is equals to the AK intersect with the pre-images of AL, where K and L runs from 1 until N. So that means if you join with the pre-images, so you have to find the intersection between each elements in the partition. So if we join 3 partitions, for example, so the psi will and then we join with the pre-images of psi, and we join with the second pre-images of psi. Okay, so you will have AK intersect with TAL inverse intersect with T minus 2 of AM, where K, L, and M runs from 1 until N. So how many times that you can do it? Macam M square. M cube, sorry. Sebab dia ada 3. So setiap tu, you have to find the intersection. So in general, you can write, so there are so many partitions, right? You can be infinitely many partitions or finitely many partitions. So you can write in general form. So I have the join is from of k from 0 until n minus 1. The pre-images of minus k psi is equals to 1. So you can write as psi join with t inverse of psi, join with t minus 2 of psi, join until join with t of minus n minus 1 of psi. So the total element in your join partitions is n power m or less. Sebab apa n power m? Sebab kat sini lah. Kalau 2 partitions here, you have n elements. Kalau you join 3 partitions here, you have n square elements. If you join 3 partitions, sorry. Ini n elements, ini n square elements because there are 2. Yang ni n cube. Because you joining 3. So kalau m times you join the partition, that means there are n power m elements or less. It can be less sebab kadang intersection we can have empty set. But the maximum is n power m. So the entropy of the join. Okay. Finitely joining partitions. So we call this as the finite partitions. How to find the entropy of these finite partitions? So how to find it? That means you have to use the limit. So h. So we use the small h now. So the entropy of the transformation with respect to the partition. So this is, we call it as the entropy of the transformation with respect to the partition is equals to the limit of m from goes to infinity 1 over m of the entropy of the finite partitions. So if the limit exists, then you can entropy. This is the formula. Okay. I think I'll stop here. Maybe next class we will do this example. Because if I want to consider this example, it takes a long time. So at least you know. So if you join the image and the pre-images, okay, here you have at least n to the power of m elements because we consider the finite partitions. And by how to find the entropy of this join, finitely many m partitions, so you can find using the limit. So to find this limit is we use this formula. So that means we want to find the entropy of the transformation with respect to the partition. So that means we have to use the limit. Kalau H kecil, you have to use this limit. Kalau H besar, you have to use the formula for the entropy lah. Okay. Any questions so far?
Tak ada.
Tak ada.
Kalau
Alright.
kalau yang H
yeah.
kecil ni guna untuk partition je lah.
Dia ada, ingat mula-mula masa saya define steps tu, we have 4 steps. First, kita ada entropy biasa. Next, kita ada conditional entropy. Next, we have small h. And next one, we will have h and t saja. So that is, now we have come to the third part. Kita nak ada h. So this means that our h, small h ni maksudnya kita kena guna limit. Okay, so kita small h maksudnya on the partition sahaja. Respect to partition. Sebab dia ada comma kat sini. Dia bukan conditional tau. Dia bukan conditional. Dia entropy of the transformation with respect to. Maksudnya dia ada partition dia. Okay. Next class I will show you the example and then kita akan cuba fahamkan lagi lah. Okay, just to recall sekejap. In lecture number 9, yes. In lecture number 9, first steps tu ada step dia. First step, kita define entropy. Okay, this one done. Next, number 2, we define entropy of psi conditional. Okay, second partition. Now, then we want to define the entropy of psi. Sorry, terbalik. Entropy of T with respect to this one. And last one will be entropy of T sahaja. So this one maybe next class lah. Okay. So now we have also done this one. Now we are in the third. We call this as entropy of partition with respect to measure. Kalau H ni dia ada H sama ada psi dengan T, or it can be H of T and psi. So here kalau H and T and psi maksudnya entropy of the measure preserving transformation T with respect to partition. Kalau yang ni kita panggil dia sebagai entropy of the partition with respect to the measure preserving T. Okay. So, alright. So if there's no more questions, then insyaAllah I'll see you next week on Tuesday lah.
Alright, Doktor.
Okay. Banyak sangat kan? So first you have to ni lah, kena practice home task yang I discuss, because sometimes home task tu makes us bila kita kira tu lagi cepat lah, familiar nak guna apa formula mana. So kalau nak for more understanding, you can watch Prof Nasir punya video. Dia memang discuss sekali dengan apa tu, exercise. Okay. Cuma tulisan dalam video tu I hope you can see. Kalau tak dapat tengok, just let me know lah. Okay. Alright class.
Terima kasih tu pun tak boleh tak boleh tengok langsung.
Yang mana?
Tulisan yang Dr. Fatimah ada bagi ni juga.
Oh, tu lecture berapa tu? Tak ingat.
Yang pasal apa?
Tak boleh baca Itulah kadang masa tu ad hoc kan, nak kena buat recording. masa tu tak reti nak guna apa, tak ada device. Lepas tu handphone hang, macam-macam lah masa tu. Because masa tu first time ada PKP. So devices tu pun macam tak berapa proper lah. So that's why dia tak clear, tak dengar and so on. But afterwards, starting lecture 7 until lecture 14 tu dah okay lah. I hope lah. So that means it's okay kalau tak cuba nak fahamkan sajalah Prof Nasir punya explanation. Maybe ada orang boleh faham, ada orang kena. Untuk part ni, untuk lecture ni saya memang ulang je apa yang Prof Nasir ajar dalam video tu. Okay.
Oh, okay.
Sama je, nota pun sama, exercise pun sama. So maybe kalau dah tahu part ni boleh skip, boleh tengok part yang ujung tu lah. Part yang saya tak ni, tak cover bahagian ni. So next time bila kita buat kelas, so maybe dah cepat sikit untuk faham. Okay.
Alright.
So any more?
No.
No, okay, good. So see you next week lah, insyaAllah. Stay safe everyone. Thank you for your patience and thank you for your attention. I end this class with Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam. Thank you, Doctor.
Welcome.
Thank you, Doktor.
Thank you,